Hello, everyone. Welcome to another episode of Math with Audrey. We're going to get this done. We're going to end this day on a good note. And today we are working on exponential and growth and decay. So before we go anywhere, let me see if I can angle myself here. I know everything's all kinds of crazy. Cookaboo Johnson. There we go. All right, so we are going to do like a quick review on exponents. Some people are getting it, some people are not, but it is essential. All right, so main thing, when you have the same bases. And if you're like, okay, Audrey, what is a base? Well, let me slide over here first, okay? So 5 squared, that whole thing is called a power. Now, the 5, that's your base. The 2, that's your exponent, okay? So the 2 is basically saying, how many times do I multiply this base to itself? So if I'm saying 5 squared, this is the same as saying, I'm going to put my equals, 5 times 5, okay? It is not 5 times 2. I've been dealing with this all day, so if I feel a little it's because I've been dealing with it all day. And I was like, you know what? Before I do my next part, I gotta make sure I'm gonna be doing this part right here. So if it's 5 to the second power, it does not mean 5 times 2. All right? Anytime you see a number that's being elevated, okay, that is being raised, you are basically multiplying this base by the number that is being represented as your exponent, okay? So we know that 5 to the second power is equivalent to 25. Okay, so I've been like a little bit on edge about this today. All right, it's like, so with that being said, we have a couple rules that we need to abide by. All right, so we can zoom in on my little formula section. I'm just going to use them as rules. The first one, when you have the same base, okay, you are adding the exponents. So a to the 4th power times a to the 3rd power. I still have my base of a, but I'm going to add those exponents, not multiply them, okay? Now, 4 plus 3, that's where it gives you 7. When you divide, you're going to subtract them, but you don't subtract from the bottom to the top. You start from the top to the bottom, okay? The exponent in the numerator minus the exponent in the denominator. So they have to have the same base, which is b, and then we subtract the exponents. 5 minus 3, that's where the 2 came from, all right? Thank you for all that are popping in, joining in. I appreciate it. Hey, film artist, how are you? All right. Hello, everyone. Thank you, Teresa. How's it been? It's been a minute. All right. So now, the other one, which I forgot to put in, let me see if I can put a little zazzle before I start talking about the negative exponents. There is one. So if I have d to the 4th power, and that's being raised to the 3rd power, okay? This is the one that you multiply, okay? Not, let me see if I zoom in a little bit more, okay? When it's just a power being multiplied by a power like this is when you add the exponent. But when you have a power being raised to a power, that's when you multiply the exponents. The reason why you're saying that the base and its degree, d to the 4th, that means I'm multiplying it to itself 3 times. And if I'm multiplying and they have the same base, that means I'm adding the exponents, right? So you got 4 plus 4 plus 4, that gives me d to the 12th. Now, instead of extending it out, this is what you can do. You have your base of d, and you are multiplying your exponents. So when you see a parenthesis, when an exponent is being separated by a parenthesis, you're multiplying. When it's just being multiplication like this, you're adding the exponents. Do we see the difference? Entertain me. Hey, Leanne. Okay, do we see the difference? Okay, there's a difference. When there's a parenthesis and a power is being raised to a power, you multiply the exponents. When it's just multiplication like this, you're adding the exponents. All right? Okay. Now, the negative exponent. Not the negative base, but the negative exponent. If you ever get a negative exponent, you basically do what's called flipping it. Okay? So if we have c raised to the negative 5th power, that means I can put this bad boy over 1. So when I flip it, that means the 1's going to be on top, and c to the 5th is going to be on the bottom. Okay? So because your act of flipping it is making that positive. Now, here's the other thing. What happens if the negative is already in the denominator? Do you just leave it? No. Okay? That means you're going to have to flip it. So that means c to the 5th is going to be in your numerator. The 1 is going to be in your denominator, but we all know anything divided by 1 is itself. Okay? So by doing the opposite or putting it in the opposite position, you're making that you're negating, is what they're calling it. You're negating the exponent. All right? And now, rain is gone. Good. Taking my prerequisites. Why are you terrified of taking your prerequisite? Don't be terrified. I know there's like a lot of things happening all at once, but you gotta understand, it's hard for you to go in there and try to cram all this stuff into your brain. It's not gonna work. Just just embrace the experience. Just try, look at it. Let's see if I can remember it. Great. If you can't, that's okay. Okay? And plus, you're telling me it's the prerequisite. Relax. You're putting way too much pressure on yourself. You're thinking like this is Squid Games, like you get a question wrong, and then that's all. That's what last thing that wrote. Excuse me. All right? So, these are the main ones. There's some other ones, of course. Anyone knows that if you have, I won't use E. I'm going to use F. So if I say F to the 0 power, that will give me 1. Anything raised to the 0 power is 1, not 0. Okay? If you don't remember anything, remember that. All right? So, what we're going to do right now, we're going to jump in and we're going to see if we can do a little bit of solving, okay, before I get into the growth and decay section. So we're going to be doing some things. This is the review, and then we're going to do some growth and decay, all right? So for this first one, we have 5 squared times 5 to the 6th. All right, what is my base? Put it in the chat. What is my base? No fear. No holes, no bar. None whatsoever. All right. Hello, Tamika. Yes. 55555. Yes. The fake phone number I used to give back in the 90s. All right. So we have our 5. What are we doing with the exponents? Are we adding them or are we multiplying them? And Lisa's here, Michael's here, hello, good. Femstar is saying we're adding them, yes. Amon said we're adding them. Kenzie, hey Kenzie, yes, we're adding, yes. Tamika, adding. Now, if we add it, and I think it was Lisa that says it's an 8. Do we agree with Lisa? 5 to the 8th power, are we agreeing? Yay, nay. We could pretend that we're Nero. Thumbs up or thumbs down. We could say yes or no. Of course, Lisa, you're going to say yes. Yep. Yes. Why? Awesome. Yes. Good. Very good. Okay, Mackenzie Lane saying yes. All right. Okay, so now this is done. You don't have to put in your calculator unless they ask for it, but I'm going to tell you right here and now, they're not going to. Okay? All right? Slide some oil to me. So now, let's take a look at this one. So, y to the 4th times y to the 3rd times y. Let me do it this way so your eyes won't be like, there's so much stuff in front of me. Okay? All right, y to the 4th times y to the 3rd times y. Okay, what is my answer? What do you think? All right, so, hey, Kelly. So we got y, Lisa saying y to the 8th. Love Lola saying y to the 9th. Go ahead. Hey, Bridget. So lovely to see you. Oh, she changed it to the 8th. Okay, Pix saying y to the 8th. Ellen saying y to the 12th. Philmar saying y to the 12th. Bridget saying hi. Kensley saying 8. Michael saying y to the 12th. Okay, so let me... What operation is going on right here? What operation is going on right here? I got the 8th and I got the 12ths. Okay. Lisa's kind of pinpointing a little bit. Okay. This is multiplication. Okay. This is multiplication. In between, we don't see plus signs or minus signs. It's not being raised to another power. So if it's just multiplication, just like what Lisa put up there, I think she was talking to Michael, if I'm not mistaken. We are going to add the exponents. Okay? We have a 4, we have a 3, and if you don't see anything, it's assumed to have an exponent of 1. So that will give me y to the 8th. Now, if it was written like, and don't write this down, but if it was written like y to the 4th, parenthesis raised to the 3rd, if it was written like this, this is y to the 12th. Okay, do we see the difference? Trickery. It's all a bunch of sorcery. All right. So yes, it just, but when you see a power being raised by a power and it's separated, like the exponents is separated by a parenthesis. Okay. When the exponents are being separated by a parenthesis, that's when you multiply. Okay. Just because you see parentheses doesn't mean that you're going to multiply your exponents. You're actually going to add them. Okay, we got it? I know. That's why I put it like that. I know. Not to be evil, but I just wanted to show people. So at least now you can see what the difference is. Okay. So how can I solve this? 1/2 negative. Oh, Ash, you want to try to tempt me? Oh, okay. Ash trying to be grown, y'all. All right. So it's just like what I was saying. When you have a negative exponent, you flip it. So you flip the fraction. So it's 2 over 1. And by flipping the fraction, you change the sign, which is 2. 2 raised to the second power, that gives me 4. 4 over 1 will simply just give me 4. I know. She's like, no! No worries, no worries. I'm just being silly. It's been a crazy day. I feel like I've been repeating myself like all day. Okay, does that make sense, Ash? Because when you guys have a negative exponent, that fraction, flip it. Okay, now the 2's the numerator, the 1's the denominator. By you flipping it, it's negating or making this into a positive 2. So then all you have to do is square everything. So you square the 2 and you square the 1. So 2 squared gives me 4, 1 squared gives me 1, but 4 divided by 1 will just give me 4. Okay? All right, how are you feeling now? On the outside of the parentheses mean. So that's how many times you are raising that base. So like if you said, let me switch it up this way. So if I said y to the 4th raised to the 3rd power, that means I'm doing y to the 4th multiplied by y to the 4th multiplied by y to the 4th. So that means I'm basically writing out that base 3 times. And since I'm multiplying, I add the exponents. So 4 plus 4 gives me 8. 8 plus 4 gives me 12. So this will be y to the 12. Okay, let me see if I'm catching up. All right, doing G. It's basically a GED question, especially these. How many copies to make of whatever is in the inside? Yes, you can say that. Good. Oh, this account is currently saving me in my math class. We're learning this as we speak, and I'm lost. Okay, Ashley. All right, good. Okay, so we're good. We're all right. We're okay. I did not hear, or maybe I did. Hold on. Let me take a quick little. Okay, so Ash, going back to this. Are you okay with this one? Oh, sorry. Okay. Are we okay? Are we okay? Are we okay? All right. Maybe Ash escaped. I hope I didn't shung her. Okay. Of course. Another one. Michael, like, you think I wouldn't have another one? Oh, I got a whole slew of them. A whole slew. All right. So let me get you guys focused. So that is multiplication. Let's focus over here. Let's see if I got you. Got like white paper everywhere. All right, bam. All right, so let's focus right here. So we have 6 to the 13th divided by 6 to the 2nd. So if we know that when we multiply, we add the exponent. So when we divide, we do what with the exponent? No, Lisa's on a venture. She's right there. Okay, we're going to subtract the exponents. Good. So we still have that base of 6. And then we're going to subtract 13 minus 2, which a couple of you already have, which is to the 11th. Okay. Because I could just print out 13 sixes across here, which I'm not. And then on the denominator, there's 2 6s. And then I can cancel out 1 set, 2 sets. And what will remain in the numerator will be 11 of the 6s. Okay. All right, so when you divide, you subtract the exponents. When you multiply, you add the exponents. All right, now, let me move this over so we can step our game up. And you're like, oh my goodness, what is this, Audrey? Why is there a number in front? Because there is. You'll be okay. Actually, I should just do it like this. All right. Do not freak out. Okay? Do not freak out. I know you're freaking out. Just relax. Okay, good. I know. All right. Can you show the formula again, please? There's multiple formulas. So just that formula section? Sure. Let me tilt it. Okay. So you don't know if you passed that question. Okay. All right. Okay. Not a problem. All right. So for the next one, we're going to focus on this section here. So we have 10 a to the 7th, b to the 9th, over 15 a to the 5th, b to the 10th. Now, we have some multiplication going up in the numerator and the denominator, but we don't have like terms because they are not the same basis. But if I notice, there's a's in the numerator and a's in the denominator. So here, I should be doing what with the exponents? Okay, so I should be subtracting them. Okay, anytime I see a fraction, that's division. Good, good. We should be subtracting, subtracting, subtract. So, not the whole numbers. Okay, remember, we're subtracting the exponents. The whole numbers, as someone said, hold on. See, I do see what you guys are saying. Okay. Someone says reduce. Who said that? I think that was Lisa. Yes, it was Lisa. Lisa's like on point tonight, girl. What you doing? Okay. All right. So you have 10 over 15. So we have a to the 7th and a to the 5th. So 10 over 15, we're going to deal with that in a second. But with my a's, we're going to subtract them. So that will give me a to the what? Okay, a to the 2nd. Now, is a to the 2nd going to be left in the numerator or in the denominator? Hey, Melissa. Abdul, how are you? Okay, up in the numerator, the top. Good. So we're going to leave it in the numerator. Okay, because you would have 7 a's in the numerator, 5 a's in the denominator. If you were to cancel out, you know you'll have 2 left over in that numerator. Now, b to the 9th over b to the 10th. Okay. True. The 10 is going to borrow. We can say that. Or think about it. I got 9 b's in the numerator. I got 10 b's in the denominator. How many b's are going to be left and where is it going to be located? I think someone said it. Yep. I think Jonah, Aaliyah, Lisa, Ella. What we got? Kenzie. Yes. Okay, so that b is going to be left, and it's going to be left in the denominator. Okay, because we had 9 b's up top in the numerator. We had 10 b's in the denominator. If I cancel out, I'm going to have 1 left in that denominator. Okay. All right. So I don't have to make this into a -1. If I just did the subtraction and put b to the -1, then I would have to drop it down in the denominator to make it positive. If you know that you're going to subtract, then you're going to have more in the denominator, just put it in the denominator. Why we got to be so technical? Yeah. Yep, it could be -1 on the top. But here's the thing, Abdullah. This is the thing. A lot of us don't like to have negative exponents. They will always say make it into a positive exponent. Leave your answer with a positive exponent. So they're always going to say that. Now, if you want to put a 1 in the exponent spot, you can do that too. That's perfectly fine. As long as you know that when you look at your answer choices and 1 is not there, don't worry about it because it's just going to be just the letter B. Okay? Okay. All right. All right. So a random question, but when can you or are you going to go over functions? Not tonight, actually. Not tonight. Okay. So now, 10 and 15. 10 and 15, I can't just divide that because that's going to give me a decimal. But I can reduce it. And I know Lisa has it. Yep, there it is. And then Jonah, good. All right. So if anything, we have 10 and we have 15. What do they have in common? What are they multiples of? What are they multiples of? Good. 5, 5, 5, 5. Awesome. So that means if I divide this 10 by 5, I'm going to get a 2, and that 2 is going to be in the numerator. If I divide this 15 by 5, that will give me 3, and that's in the denominator. Okay, so it's going to be 2 over 3. Yes, there you go, Ash. Good. Okay. So whatever they have in common, reduce it by doing the division. Okay, reduce it. That's how you deal with fractions. This is another thing that was driving me nuts today. Okay, so, I mean, if you have 14/16, okay, both of them are even numbers. And they're part of the what times table? They're multiples of what? I do not, Abdul. Okay. So by 2's, good. So that means if I just divide that numerator by 2 and that denominator by 2, 14 divided by 2 will give me 7. And 16 divided by 2, that will give me 8. So we reduced to 7/8. Okay? Is everybody all right? Are you seeing it? Yay or nay? Okay. All right. Now, good. Walt, wait, what? What happened? What am I waiting? I see my error. Okay. All right. I just made that up. So don't worry. She was like, wait, where did that come from? I just made it up to show the reduction of fractions. Okay? Amelia, please don't lose me. Okay? You're okay now? Yes? No? Are you Okay, there we go. All right. I was like, are you creating a voodoo doll with my name on it? What is this evil that she keeps doing? And another one. Yes, Michael. Such a tyrant. Such a little tyrant. Okay. All right. Oh, sorry. Okay. But it's fun. It's always fun. I like the challenge. All right. So we have 4x cubed yz raised to the third power. Okay? Raised to the third power. So now, if I look inside the parenthesis, there's nothing I can combine because all of the bases, including my coefficient, is completely different. I can't like combine anything. You can't mix x's with y's or y's with z's. It's almost like you can't mix certain drink things together or you'll be up all night, right? So you don't have anything inside the parenthesis. But everything inside that parenthesis is being raised to the third power. So that means everything inside this parenthesis needs to be raised to the third power. So that means the 4 needs to be raised to the third power. Okay? The x cubed needs to be raised to the third power. The y needs to be raised to the third power, as well as z needs to be raised to the third power. Okay? If we want to put parentheses around everything, we can. That's perfectly fine. Okay? I like to put parentheses around the original. Actually, I kind of went a little too crazy with that last one. It should have been just the 4. All right? So now, okay, I got a couple rock stars in here. That's also not the whole thing. All inside. Yes. Okay, so everything is being raised to the third power. 4 to the third power. It's not 12. Please don't say 12. I know you're gonna. I know Michael's probably gonna put 12 up there just to pluck my nerve. Right? But it's not 12. It's 4 to the third power. So that means 4 times 4 times 4. Okay? I don't want you to lose points on small things like this. Okay? So 4 times 4, that's 16. 16 times 4, that's 64. Okay? All right? I'm starting to know you, Michael. It's only been 2 months. All right, good. All right, now, what are we? Let's see if I can cover up this so you can zoom in right here. Okay, focusing right in the red, looking at the red. X to the third, raised to the third. What is my answer? What would the answer for that be? Just what's in red, not what's in green. Ignore that. But I'm causing a shadow, so I don't like that. Just the red. What would that give me? Put it in the chat. X cubed raised to the third power. What would that be? Remember, question marks is also an answer as well. I will take that because I will be able to explain because I know some people came in here a little bit later. All right. Like Monica's lover is in here. Kaden, good. Am I not seeing? People are putting things up. Hold on. On my computer, I'm not seeing. Oh, look. All these answers. Let me just scroll a little bit more. Yes. Okay, I'm seeing X to the ninth. X to the ninth. Not so much 81 because we don't know what X is. Okay. But I do, and not so much to 27 because I don't know what X is. So I do have X to the ninth, X to the ninth. Okay, not x to the sixth, because remember, it's being separated by a parenthesis. Okay, so your exponent is being separated by another exponent. So this is telling me multiplication. So it's going to be x raised to the 9th power. So we got our x to the 9th. Okay. So here for the y, that's easy enough because that has an exponent of 1. So that's simply going to be y cubed. And the same thing is happening with the z. That is z cubed. Okay. So your complete answer, which, let me see who originally had it. I think Caden was the first, and then, yeah, Caden had it. Monica's lover had it. And I just had a test on this yesterday. I know. It's like I always I'm right there with you guys or I'm just missing. Because a lot of my kids were having this today. Okay. You had the 64 wrong. Okay. All right. Yeah, because a lot of my students was like making me crazy with this today. Cray cray. All right. So let's step it up. Because I know Michael probably said another one. All right. All right. Cool. Let's do this. Okay, I'm going to cover this one. I don't even think that one's in sight. Let me raise this bad boy up a little bit. All right, so we got a combination going on here. Of course she did that. All right, so we got a nice little combination. All right. So we have 3a raised to the negative 4th, b to the 7th. All of that is being raised to the 3rd power. Should I leave you alone, see what you guys can get? I know some of you guys could be like, hell no, but give it a try. Okay? Give it a try. Again, if you get it wrong, am I going to come to your house and just rate it? No. I'm not going to, right? 1, super tired. Super tired. And then 2, no, it's not going to happen. You're going to live. Everything else is going to be fine. If we have to if we have to correct, then we'll just correct. We'll make corrections. We are not perfect, okay? Sheesh, give yourself a little bit of patience. Come on, give it a try. Give it a try. Shane Dog, what are you talking about, babe? Are you telling me my answer? Okay. Yeah, we're not doing logs tonight. It will be coming, though. I think it is going to be this week, but it's not going to be tonight. I think that was Young KJ? Oh, and here comes the other Michael. It's going to be a Michael night. And Wendy's coming in. Oh, I'm thinking everyone here. Hello, Michael. Right. So you just have to finish it out. Yeah. Dealing with math, sometimes you do have to have patience. You have to give yourself some kind of patience. And I know it's hard because the classes are getting faster. Fairly recently, I had that lovely discussion. So I'm still waiting for the powers that be to get back to me so we can sit down and have a powwow. Because this stuff doesn't make any sense. Okay, all right, so we got a couple decent answers. Okay. All right, somewhat ready to go over. Okay, hit the lights so I can see if you guys are ready for me to go over. You see how I did that? It's so pathetic, right? It's like, please like my stuff. Please give me like, show me love. So I have appreciation. And while some of you guys are tapping the like button, which I appreciate it, it's not like you can't over tap it. Really, you really can't. But I don't know what's happening. A lot of people are still not talking about April the 4th. Remember, that was supposed to be the next deadline for TikTok? I have no idea. But if they do like a typical 10-hour shutdown like they did last time, okay. I will see you on YouTube. And if anything, you can always go to my YouTube channel, which is, it's kind of a little zoomed in. It's like Audrey Codner, ACG Math Tutoring. So if this ever shuts down, that's where you can find me. I'll go live there. Yeah, hands down, I'll just go live there. Okay? So if you ever need me, that's where I'll go. I'm not going to go on Facebook. It's too bougie there for me. I guess I'm just too, under the radar for them over there. All right. Okay. Skylight? What is that? Every time I turn around, there's a new app. Okay, I'll check out Skylight. What the heck? First it was Lemonade, but I was just like, I feel like that's not me because I can't do any videos on Lemonade. So I was like, okay, I'm out of that. But we'll figure it out. I will try Skylight. Skylight. Okay. So now, we can't do anything inside the parenthesis. Everything needs to be raised to the third power. So that means the 3 needs to be raised to the third power. That a to the -4th needs to be raised to the third power, as well as the b to the 7th needs to be raised to the third power. All right? So 3 to the third power, that's 3 times 3 times 3. That gives us our 27. And then if I multiply my exponents here, I'm going to get a -12. But I can't have a negative in my answer. My answers have to be positive. So that means this bad boy needs to drop down into the denominator. So that means my a to the 12th will be down in the denominator. Then we have b, 7 times 3 gives me 21. All right, and this is my answer. How'd we do? Yeah, Lemonade's owned by the same company. Yeah, and plus it's like a bunch of carousel. It's almost like Instagram and Pinterest had a baby. And if you're talking about something else other than politics or nails or fashion, I just don't really fit in. It's just not for me. For a G exam too. Yes, for exponents, yes. Yes. Okay. You do when they're the same base. but they're not the same base. Okay? If this was an A and this was an A, yes, there'll be some subtraction going on. But they're not the same base. Okay? All right. Not matching. Yes. Definitely got to match it up. All right. Okay. One more. One more. Gonna slide this bad boy over. All right, this is the last one for this because I definitely wanted to talk about exponential growth and decay. And then what I will do, I think I might try to do something a little different tonight. Just a little bit. Yay. All right. So we have a to the negative second, b to the negative fifth, over c to the negative 11th, all being raised to the negative sixth power. Okay? Don't freak out. It's okay. Think about what your plan of attack is. It's like the art of war. Think about what is the enemy. What can you take the easiest but yet effective route to conquer this problem? I feel like a CSI sound should come in the background of that. Dun dun. So we got Sam. Lots going on, yes, but don't look at it as one big whole thing, Michael. Step at a time. Okay, so Sam's got an answer, Lisa's got an answer, Daryl's got an answer. But are they right? Are they right? Okay, always double check, double check, double check. You'll sit this one out. Why? Try it. Try it. Okay? Because user 1882301314855 kind of gave you a little hint. Try to say that 28 times fast. You could, Pog, but do you have to? It's almost like you could blow up the door, but it's unlocked. You could kick the door in, but it's already open. What could we do? So much anticipation. This is driving you crazy, Sam. Is it? Is it like really like It's all right. Okay. All right, we got. So, Michael, you got part of it. I mean, I don't know about just ignoring them, but you know. Okay. There we go. Now you see that the door's open, Puck. There you go. There it is. Okay. All right. So, you know that everything is being raised, and all three of the terms inside of the parenthesis are negative. And it's also being raised by a negative. So you could flip all that stuff. But guess what? You can still tackle it with a to the negative second be raised to the negative 6. B to the negative 5th being raised to the negative 6 over C to the negative 11 being raised to the negative 6. So now we have an exponent being raised by an exponent. So that means we are multiplying these exponents. Take a look. Negative times a negative, negative times a negative, negative times a negative. Negative times a negative will give me my positive, right? So then let's finish it out. That means A is going to be raised to the positive 12. My B is being raised to the positive 30th. And then my C is being raised to this positive 66. And since they're all different bases, I can't combine them anymore. All right. How are we feeling? Yay! Okay, do you feel better, Sam? You're like, just answer the question. I know. But see, my thing is, if you're somewhat new to my lives, I like breaking down math concepts. But I break it down to the point where almost everyone can understand. If you are the type of person that you get the answer so quickly, this is not the live for you, right? Because there's so many other people that are doing challenging stuff that you can easily join up. I would love to keep you, but I don't want to hold you back. All right? So that is the basic review for exponents. Okay? Please, for heaven's sakes, do not lose points because you went 5 times 2. Trust me, that answer is going to be an option. They do it every single solitary time. All right? So remember, sorry, I'm getting a little violent over here. Okay, so when you're multiplying, you add the exponents. When you're dividing, you're subtracting the exponents. When you have a negative exponent, flip it. If it's in the bottom, you put it to the top. If it's on the top, you put it to the bottom. And if you have a power being raised to a power, you multiply the exponents. Okay, and anything raised to the 0 power is 1. Okay. So I know some of these tests are timed and you're like, I just really want to get it all done. Well, there's going to be times you're going to have to take a moment, take a look at what you're about to do. You know, you can't just jump into conclusions. You got to take a look at everything that's being offered. And then you go with your assumptions. All right. So next part, reason why I'm doing this. Peggy! Oh, wait, I'm sorry. Let me get a screenshot of the page. Ready? Do what you can. Exactly. Inverse and inequalities right now on my algebra class. Okay. So inverse of what? Are we doing sine, cosine, and tangent? Or what? Sorry, I had to be all dramatic with that. Yes, the double negatives do tend to get people. All right. So tonight, we're going to talk a little bit about exponential growth and decay. I'm doing the simplest of the simple. I'm not trying to get all into fancy and stuff like that. The main thing that you need to remember, I'm going to come here and then basically this is the same that's over here. So let me zoom. Woo, that was crazy. Here we are. Now, we're used to seeing anytime that's exponential, there's an A, there is a b value and it's being raised to an exponent. Sometimes you may see it as AB. Sometimes it'll be A with a dot with the b raised to the x, or sometimes there's a parenthesis around the b. Okay? Either way, this is exponential. Okay? Meaning, think about when you're in your office or your classroom or somewhere at work, and you got that one person, I don't know why they do this. They trying to be all big and strong, knowing that their asses are sick, and they come to work. All it takes is one person. They're like, well, it's allergies. Well, then keep it at home, right? All of a sudden, the next day, someone else is like, oh, my throat's scratchy. Next thing you know, you got 3 people that's sick. Then you got 10 people that's sick. Then before you know it, almost the whole classroom is sick. Okay, then the teacher gets it. And we as teachers, we keep like, oh, I feel better. And then you get sick again because you're not completely healed. All right. That's something, even if you look at the pandemic, first it started off really slow and then bam, it just exploded, right? Sorry, I probably scared y'all. And it completely exploded, right? Then all of a sudden it spread like wildfire. That's exponential growth, okay? Exponential decay, we can say it was on the decline. Finally, we start getting some medication. Then all of a sudden, it started really dropping down a little bit quicker. It was a little slow in the beginning, and then all of a sudden, it started really dropping. And then it got to a level where people were starting to feel safe, and then we were starting to go back outside. All right? So, yeah, exactly, the vaccines, okay? So, when we think about this, I know for high school, I will always say a rumor. All it takes is one person to say, I think I like Johnny. Next thing you know, people in nearby schools, it's online, it's everywhere. You're like, oh my God, my life, right? So all that stuff. And everyone just really associates with that because that's what we do. We gossip. Now, that's exponential growth, okay? Notice the difference between growth and decay. Growth has the plus sign. Decay has the minus sign. Think about it. Okay? You bought a brand spanking new car. Got everything in it. No one has even put their butt cheek in there. Like, I'm talking fresh, right off the freight, right? I don't know why you did that, but here you go. As soon as you drive it off that lot, the depreciation kicks in. Like, literally, the first tire. It don't even have to be all 4 tires. Just one of them. There it is, okay? It depreciates, okay? It's not worth what you sell. So if you tried to sell it for what you just paid for it like 2 days later, you can't, okay? You can't. So that's kind of the depreciation, the decay, that's there. Rumor spreading and the huge growth expansion, that's going to be growth, okay? All right? So as long as we get that part down. So now, I'm going to try. Yeah, I think we can do this. Here we go. All right. So we have an equation. I just took it from a sheet of paper. It was just so much easier for me right now. So we have y equals, let me see if I can zoom so you can see it. So I have y equals 5,575 times 65 hundredths raised to the t, okay? Your a value, if I may, okay, your a value is always your starting point. Okay, doesn't matter if it's a growth or decay, your a is always your starting point, okay? Your R is your rate. The R is the rate. So if they give it to you as a percent, you have to turn it into a true decimal, okay? So you're going from a percent to a decimal. Okay, even if there's a decimal already in there. Okay, so that's going to be your R. So just by looking at this example, is this going to be an exponential growth or decay? Yeah, I already have a video on compound interest. That should be on my YouTube channel. That should be out there now. Okay. So, 0.65. Do you think it's going to be a growth or a decay? Okay, Michael R. says decay. What do you guys think? If you can guess. Oh, here we go with this thing. This is the one thing it annoys my life. Oops. So now my thing is all kinds of wonky. Okay. So only got one person that wanted to say decay. Everyone's just not too sure. Okay. Think about it. If I'm supposed to add the rate to 1 for growth, obviously my answer that's going to be representing my B spot is going to be bigger than 1. Whereas for decay, I'm doing 1 minus the rate. So that means my answer is going to be less than 1. So if I'm coming over here and I look inside the parenthesis and it's not more than 1, that means it is exponential decay. Okay, good job, Michael. It's going to be decay. So all you have to do is look at the formula. So the very first number is going to be where they're going to start. Okay, so it could be a car, maybe a used car, I don't know. That was like where they paid $5,575 for it. Okay, this is basically talking about the depreciation rate. Okay, and you can probably calculate how much that vehicle is going to cost after a certain amount. But in order for me to get that 0.65, I had to have 1 minus my rate in order for me to equal that 0.65. So what would be my R? What will be my rate? My actual rate? What do you think? So less than 1 is decay, greater than 1 is growth. Yes. Okay. For some reason, I gotta scroll nowadays. Yes. So yes, I'm seeing 0.35. I'm seeing 0.35, 0.35, 1 minus 0.45. So not 45, but 65. Okay. So it is going to give me 0.35, which is what as a percent? What would that be as a percent? 35 hundredths. What would that be as a percent? Yes, Jordan. You have Visit Jordan. It says 35%. Okay, remember, it's always out of 100%. I don't know why they always say, you have to do 110%. No, ugh. Just work hard. Okay, so it is going to actually be over 35%, 35%, not 65%. Okay, this is what we got. Let's see, there was a number, 1 minus a number was giving us that 0.65. We have to figure out what that number was. So that number is going to be your 1 minus 0.65. That will give you your 0.35. So my initial, so they ask you what my initial value is. My initial value was 5,575. And then when it says, what is the rate of growth or decay? Well, in this case, it will be decay. And what was the rate? That means what was my R? My R is going to be 0.35 or 35%. Okay. How did you get the 35? So if we have, because inside the parenthesis, they gave us 0.65. So if 1 minus something, because it's decay, is going to equal 0.65. So in order for me to figure out what this R is, I would have to say 1 minus 0.65 to figure out what that R is. So 1 minus 0.65 gives me 0.35. Okay. So anything over 100% is wrong math. 100% is the max. I swear, yeah. But I know, when it comes to statistics and everything else, they have more than 100%. Okay. All right. Add the R across to subtract that in case anyone didn't catch that. Okay. Okay, so it's 1 minus the rate that they gave you, which was inside the parenthesis. Okay. To solve the variable, yes. Okay, I got it. Okay. All right. Let's try another one. Another one. Yeah, I didn't know how much room this was going to take, so I was like, let me not pre-tape it. And if you want to tap while I'm taping, that would be awesome. Okay. Yeah, this will save me some time instead of constantly keep writing. Okay. All right. Well, thank you so much for the love. Appreciate it. Oh, bundles of blessings. How are you? Okay. So now, oh, thank you so much. I appreciate that, film artist. I really do. All right. Here we go. All right, so we have y equals 10 times 1 plus 400ths raised to the t. So does this function represent a exponential growth or an exponential decay? What do you got? Okay, Melissa's like, bam, growth. Okay, oh, thank you. Okay, hold on. Okay, Nano saying growth. Vicky saying growth. Lukey, growth. What was it? Oh, Sloppin, growth. Pollen, growth. Tamika, growth. It was growth. All right, growth because it is more than one. Excellent. Right. So this is where you're looking at. Actually, let me highlight it so you have an idea. Okay, inside this parenthesis, that's where you're looking at to tell if it's growth or decay. If it's more than 1, it's growth. If it's less than 1, it's decay. All right, so since we got this plus sign, we could simplify this a little bit more. We could simply say it's 1.04. That's another way. Okay, instead of keeping the plus sign, you can do that. So since this is growth, now what is my initial value? What would be my initial value? What did I start off with in this case? Okay, what did I start off with? What was my initial? My initial amount, my initial number of, I don't know, flowers. What was my starting number? Okay. So we got 10, we got 10, we got 10, we got 10. 10, 10, 10. Good job, guys. Awesome. 10, 10, 10. Yes. So no matter what, this is your starting number. So that is going to be 10. So now this is where we're going to have to be a little tricky. What is the rate, and since we said it's growth, what is the rate of growth? What do you think is the rate of growth? I'm curious to see what you guys see. Okay, what is the rate of growth? Duck, you're close. Is that duck or black? I don't want to insult, so I don't know. Educate me. Okay. So I have Pog. I have Nyan. No. Pog, Michael, Nisa, Jaren. Okay. Nisa, don't change your answer. She's like, oh, I don't know. I'm like, no, don't change your answer. You actually got it right. Okay. It's not going to be the whole thing. It's not going to be the 1.4. Remember, it's 1 plus your R. Okay. Let me go back to growth. Let me slide up here. Here's the formula. It's 1 plus your R. So if they ask for the growth rate, they're looking at just the R. And in this case, they didn't combine it. So it's 1 plus my R. So we're looking right here. So my growth rate is going to be 0.04, which is what percent? And I think Michael has it, except for he put a question mark there. Or 4%. Okay. Good. All right. Okay. So we're not adding anything. We're basically like kind of taking bits and pieces of the formula. Okay, taking bits and pieces of the formula. Let's try another one. No, the growth rate is not 104. It's got to be the rate, not the one that you're adding to it. But you can argue me. That's fine. Trust me, I'm not losing any sleep tonight. Okay, so the growth rate is just the rate, not that whole expression. Do, 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 do. La, 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 la. there's Michael. Another one. Okay, so I'm going to leave you alone with this one. Let's see if you can get this one. And it's basically asking the same questions. I'll see if I unzoom so you can see it a little bit better. All right. Okay. All right, so we have 2,250 times 1 minus 0.9 raised to the t. Now, do not put your answers in just yet. Just go ahead. Okay, I'll explain a moment. So tell me, is it growth or decay? What is the initial value? And what is either the growth or the decay rate? Okay. I think it'll be better if I zoom in. Okay, so is it growth or decay? What is the initial value? And what is the growth rate or decay rate? Okay, hold your answers till the end. Yeah, Joe, I do not. I do not do calculus. But I do have a guy, if you seriously need a calculus person, just go ahead and message me. And I'll hook you up with my calculus person. Okay. Okay. All right, go ahead and put your answers up. You're like, I already did. I was like, I know you did. So I had a lovely mixture of decays. I had the initial values. I'm seeing some 2250s. And some people are telling me my growth rate is at decay rate, sorry, is at 90%. All right. So, where do I look? I look right here, smack inside the parenthesis. Okay, what do I see? I see a minus sign. When I see a minus sign, boom, that is decay. Okay, because it's going to give me an answer that's less than 1. So right away is decay. My initial value is the A value, or what's in front. So that's the 2,250. Okay, a lot of you guys got that part right. Now, since you know it's decay, there's going to be a rate of decay. And that rate of decay is what is next to that minus sign, which is that 0.9. 0.9 can also mean 90%. Okay, so a lot of you guys got like half of it right. Some of you guys got all 3 sections correct. Some of you guys got 2 out of the 3 sections correct. But that's where you want to look. So if you're like, oh, where do I go to see if it's growth or decay? You can look inside the parenthesis. Now, sorry, let me put my 90% over here. Okay. So Lisa, I just saw that. Do you want me to go over that again? I just saw that you said that when I was looking through. Yeah. Yep. Just look at the minus sign, it'll be decay. If it's a plus sign, it's going to be growth. No? Okay. All right. So now, if they ever give you, I'm going to add this to it. If they ever give you something like this, y equals, let's say, 16 times 3/2 raised to the x. They give you something like this. Is this growth or decay? Is it growth or decay? Okay. So I got a couple people with growth. Okay. Got one person with decay. I got an I don't know, which is an honest answer. Okay. So where we would look, again, inside the parenthesis. Okay, this is your B value. But just like what Melissa mentioned, don't, just because it's a fraction, don't say, oh yeah, it's decay because it's a fraction, because it's between 0 and 1. But is it? Okay, remember, 3 divided by 2 gives me 1.5. Okay. So it will give me 1.5. That's more than 1. So basically, we can say this. If it's an improper fraction, meaning if your numerator is bigger than your denominator, it should be, I like to say, it should be more than 1. It will be growth. Okay? Just take a moment to look. There's a fraction. Pause. Is the numerator bigger than the denominator? Yes, that's growth. Okay? We don't want to lose points on anything. Okay? All right. Okay, now be careful with terminology. It's not a parabola. Okay, it's not a parabola. All right. So having that, always look. So this would be growth. So if I said y is equal to, that might not happen, but here we are. -2 times 0.4 raised to the x. Okay. All right. Do we have growth or decay? And look at you guys with 50% growth. Yeah. Growth or decay for the next one. Here we go. Decay, 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 decay. Good. All right. So, okay. All right. So we have a decay. Now, why is it decay? Is it because the 2 is negative? Or is it because of the 0.4? Why am I shouting like you're like in the room with me? Is it because of the -2 or the 0.4? Okay, the 0.4, 0.4. There we go. All right. Okay, positive, negative. Michael! All right, because of the 0.4. All right, good. Whew. All right, so thank you, because I was about to lose my mind today. All right, so taking a quick little ganter. There was a couple people, I'm not even sure if they're still in here. If they are, that said they had homework. Anybody have homework? That closely resembles this stuff. I'm not sure if someone said that, yes or no. If they're still here or not. If you are. Okay, maybe they're not. Okay, but if you so. If you're like, oh yeah, can I do that? Because if not, I can give you one more. And I'm going to give you a word problem. So let me go to the other side. Yeah, I can't wait to get all my stuff situated, because soon enough, once I get my life together, I'm going to start charging for these pages. Because doing these notes, pain in the neck. Okay, got it? Awesome. In the future. Right, definitely, Tamika. Definitely in the future. All right, okay. So, keeping along the lines of exponential growth and decay, let's see. I want to do maybe two. Maybe two. All right. Maybe two problems. We'll see if I can. Let's see if I can fit it on this paper. Because I have this huge thing over here. All right. Just do a rough taping. All right, so here's the situation. Let me get this one little piece right here. All right, so let's see if I can do it like this. All right, so your starting salary at a new company is $34,000. I'll probably rewrite it so you can see it better. It increased by 2.5% each year. Okay, we need to write either exponential growth function, all right, to represent the situation. Why would it be growth? How did they know it's supposed to be growth? I know, I feel like I'm insulting your intelligence, but here we go. How did you know it's going to be growth? Good. Tamika's saying increase. Okay. Would the 16 be the value? Yes. For the last question, Nicole, yes. 16 would have been your initial value. I'm sorry. Okay. So yes, we got increase. Yes, film artists, increase. Okay, good. All right, they mentioned that word increase. So we're looking at that exponential growth. So remember, the original formula is going to be y equals our a times 1 plus our r raised to the x, or the t. Okay? So we're going to replace the 34,000. Where's that 34,000 going to go? Okay. Austin's saying my A. Do we agree with Austin? Okay, I got my A. It's got Lisa A, Tamika A, Bob A, Melissa A, Hergen A. In place of A, the value, yes. So that means we have y equals 34,000. Okay, parenthesis 1 plus. Now, my rate, someone mentioned it earlier. They mentioned the rate was 2.5%. We need to change this to a full decimal. Okay, we need to change that to a full decimal without the percent sign. What would that be? So careful, it's not going to be 2.5. We still need to move it. I think, oops, I don't know why my scroll's not working. Okay, I got my 0.0. Okay, Austin said 25 thousandths. Plog said 25 thousandths. Melissa 25 thousandths. Yes, Latanya, it is Latoya. Sorry, is 25%. Just have to move your decimal place one more spot, Nicole. Just one more spot. Okay, yes. There we go, Lisa. Okay, still with the 25%. Because, let me put it up here. So we started off with 2.5%. So remember, we're always thinking out of 100. 100 has 2 zeros. So I'm moving this 1, 2 places over. Okay? So that means that decimal point is going to go right there. And the 0 is going to be added. So my growth rate is going to be 0.025. Okay? And my unknown amount of years is up here. So this is what we need for part A. Okay? Are we okay? All right, there you go. So now part B asks, what will your salary be in 5 years? So if they want us to figure out what it's going to be in 5 years, where's the 5 going to go? They want us to know the salary is going to be in 5 years. Where is the 5 going to go in this equation that we just developed? Okay. We got the x is 5. Michael's saying the x is 5. Hey, Stephanie. Tamika's saying the x. And the y, we got d, the r, the x, okay, as the exponent, okay? So it is going to be our exponent. So it's going to be our y equals, the y is going to be the amount that's going to come from this. Oops. 34,000, parenthesis. So 1 plus 0.025 is just basically 1.025. And it's going to be raised to the 5th power. Now do you see why we went over the exponent stuff before we did this? Because I know for a fact, some of you will say, okay, let me multiply 34,000 times 1.025. No. Okay? Don't forget. Please excuse my dear Aunt Sally. Okay? Look inside the parenthesis. We already did that. We did the addition. Boom. Done. Now we got the exponents. So we should be combining this first. Take your solution and then multiply it by the 34,000. Okay, so this is definitely a calculator. All right, and don't round until the very end. Okay, so if you have your 1.0, well, let me just show you what I'm doing instead of me being all secretive. I don't know if you can see it. Maybe I might have to go like this. Come here. And zoom. Whoop. All right, here we go. All right, so we have, I think that's what we got. Okay, we can see it. So 1.025 raised to the 5th power, get a nice long lovely decimal. Then from here, I'm going to hit times 34,000 and hit enter. Okay. So now, okay, you can stop here. I like to get all the decimals. So then if I'm putting it in my phone, let's just say I'm using a phone calculator. You do your raising to the 5th power, right? You get this. Then you have to multiply it and just hit times. So it'll take that whole entire answer. So you don't have to rewrite it. You just hit times 34,000 and then hit enter. So now we're talking about money. Okay? We can't have all this stuff at the end. So we're looking at 3,000. I'm not sure if you can get that. 38,467. But what's my change? I feel like a kid back in the day. Give me my change. What's my change? You can. Nicole, you can do that 1.025 and multiply it to itself 5 times. You can do that. And it'll be 88. Yes. Yes. Okay, others? Yup. The reason why it's going to be 88, if I want to round it, we always have it to the 100th spot. Okay, so that means I need to look at the 1,000th spot. If it's 5 and above, which it is, that means I'm going to add 1 to the previous spot. So instead of a 7, it's going to be an 8. So our official answer, and I'm always using approximation, will give me $38,467.88. And this is the approximation because we rounded. Okay. Now, good. Yeah. Shoot. Not anymore. Not anymore. All right. Okay. Let's see. I tried to do something for my little nurses out there. Give me a moment to tape this bad boy in, and this will be our last question for the evening. I know. It's like our time just goes by so quickly, right? Hasn't done this type of math for ages. Glad I had the same exact approach. I know, everyone's doing so well with this. This is awesome. I'm like, I hope you guys are proud of yourselves because, you know, sometimes you just have to do something that you're not super comfortable with or you weren't super comfortable with because of a very poor exposure. I deal with this all day. It doesn't matter what state, it doesn't matter what country. I still get the same exact results. I keep getting kids who has a lot of teachers that know the concepts right away, but just don't know how to break it down to the students. It's heartbreaking. So, you know, I just have to be sometimes the person to help provide confidence, as well as really show them how to just do it. You know, just get to the nitty of the gritty of it. Why we got to be so extra sometimes. I mean, math is already, scary for most people. All right, so I tried something for my nurse people, for my nurses. All right, so you can come at me if you want. Don't worry, I'm not going to lose sleep over it much. An adult takes 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases by about 29%. How much ibuprofen in milligrams is left after 6 hours? All right. While tutoring your little sister? Oh, I know. Right? Oh, I don't know. Math gives you anxiety. It's hard. I mean, it is. It's challenging. Sometimes you just have to have someone that just knows how to slow it down. All right. So, an adult, 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases by about 29%. How much ibuprofen in milligrams is left after 6 hours? All right. So, growth or decay? Growth or decay? All right, I got decay. I got growth. Chocolate, I think you came a little bit later. According to the bottle, it's time to take it again, right? Okay, so we definitely got a whole bunch of decays. Okay, decay. All right, good. So that means we're using our, let me see if I make sure I'm in the spot. Y equals our A times 1 minus R raised to the X. Okay. What should go in the A spot? What should go in the A spot? For some reason, this doesn't want to scroll. Good. 400. Love it. Okay. So we got our 400 because that's what we started off with. Now, okay. So every hour, the person's system decreases is about, well, the ibuprofen, about 29%. What should we do with that 29%? Okay, there you go, chocolate. There you go. What should we do with this 29%? So we're saying 0.29. We're saying 1 minus 0.29. Which one is it? So this is the rate. The reason why I know it's the rate is because it says each hour. Okay? Each hour is decreasing by this percentage. Okay? So that means it's going to be 1 minus, as you guys all wrote, my 0.29. Okay, so we got a 1 minus that, so that's going to be just my rate. But we're not just setting up the equation and putting the x up there because it says how much ibuprofen is left after 6 hours. So where's the 6 going? Good, chocolate. Never thought I'd ever say that out loud. Good, chocolate. Yeah, it's the x, the exponent. Okay. If I don't add the 0, is it wrong? It's not terribly wrong, but try to make it a practice. Even I have to make it a practice to put the 0 to represent it. Okay, good. The exponent. So my 6 is going up here in the exponent. So now, don't forget, please excuse my dear Aunt Sabrina. Didn't sound right, did it? And people are writing and they're like, say what? 'Cause I know you. All right, so you got to do what's inside. Whoops. Let's do what's inside the parenthesis first. Then raise it to the 6th power. Then take that answer and multiply by 400 to figure out how much ibuprofen in milligrams, because we don't have to do any conversion. We just had to do expression. Yes. Sally is now Sabrina. I mean, I could say Shakira or Shaquan. I could do anything I want. But I know everybody likes Sally. Be a little Sally Walker. Okay, and then I better stop before TikTok shuts me down. Anywho. Okay. Tell me what you get for answer. You can go ahead and put it in the chat. Yeah. It will, chocolate. It'll definitely be relatable. Oops. Did you get 574? I did not get 574. Yeah, that would be way too much because that's more than the initial. Multiply. What did you get inside the parenthesis? Nicole. Yeah, because if you ever get anything larger than the initial amount and you're supposed to be decreasing, something went wrong. Yeah, I got a lot lower than that. Is it Keeger? Am I pronouncing it correctly or no? Okay. All right, so Lisa, that's what I got inside of my parenthesis as well. So 1 minus 0.29, right? So I got my 400, and I got my 0.71 raised to the 6th power. 3, 4. Oops. 5, 6. Okay. So now 0.71 raised to the 6th power, you should have gotten something like, let's see if I can do it like this. 0.128, let's say 100 in there, 2839. That's what you should have gotten roughly before you multiply by the 400. So when I take my 0.71 to the 6th power, it gave me something like this. Okay. Okay. Yes. So you have to do the exponent. So first I did what's inside the parenthesis. Okay. Wow. Then we do the exponent. We do that before we multiply. Okay. Good, Chocolate. So now multiply that by 400. Okay. Yes, Michael. That's what I got. Yes, Yan Yan. That's what I got. All right. Oh, sorry. Jocelyn. Hey, Jocelyn. Snuck in here. Okay. That's what I got. Okay. Yes, Tamika. Yes, Chocolate. Oops, there's more. Hold on. Things not scrolling naturally. All right. So we have our y equals 51. Look at me trying to do a little something for nursing. Okay, so I'm going to use the approximate symbol because we did do some rounding. And let's not forget to put the milligrams at the end. Okay, the milligrams at the end. Okay, are we okay? All right, there you go. Alrighty? Okay. Well, this was eventful. I was thinking about doing exponential to logs for tomorrow night. But I know some people are currently doing some of these things. If there's something in particular you want me to do in the beginning of the sessions, I'm gladly be able to do that. If it's any calculus, I don't do calculus. That is not my jam. I mean, I can do it, but it's been a minute. It has been a minute. So all right. So we have all of that. Okay. Questions. Where did I get this? What do I call this? This is exponential growth, exponential decay. Yep, that's all it is. No, I'm going to pass out. I'm telling you, usually March, April is my busy time because people are like, oh, wait, my child does need a tutor because they've been failing all year. Oh, okay. So for the last couple weeks have just been like tutoring 10 o'clock in the morning till sometimes midnight, 1 o'clock. Tonight, I actually get an early night and I'm going to take advantage of it. Because even last night after I worked with you guys, the exact same thing happened. One of my former kids who just came back from a track meet, she was like, I need help with blah, blah, blah. Okay, all right. We're going to do it. Oh, thank you, Michael. I appreciate the tapping. Oh, tapping for Audrey. Tap in the name of love. Can I do circles for geometry? Graphing linear equations? Where do you apply those exercises? What do you mean? To like everyday life thing or what? Oh, Professor TK. Look, I did a real life problem with nursing. I know. I tried. It was my attempt. Last minute at times. Okay. What do you mean with circles? Is it area? Are we doing volume? What do you need, Ethan? Talk to me. Slope? Is that slope? here. Okay. Thank you. My attempt. All right. So we got slope. Lengths in circles. What do you mean? The diameters? And you're looking at the arcs? Okay. Thanks for coming, Lisa. Let me know if there's something that you're going through some stuff, and let me know, because I know you have your test coming up soon. Okay. So you're saying slopes. You're saying systems of equations. I think I have that. If anything, I want to say Yan, Yani, or Yan 13. I'm sorry. I don't want to insult people's names. I just don't. Because I'm trying to sound it out. And especially with me doing it at this time of night. If anything, take a look at my YouTube channel. Because I know I've done a lot. And subscribe to it too while you're there. Math tutoring. Because I just uploaded a couple of things with GED as well. Okay, so take a look. And usually my lives, I mean, it takes me a good handful because it takes forever to upload it, to download it, all the stuff. But I put it there for you guys. And it's under a playlist named, it's very tactfully named, TikTok Lives. So you can just watch all the lives that I have on there. I'm going to try to create some shorts. Every time I want to create a short, all of a sudden YouTube is like, oh, not right now. We can't export right now. So definitely take me on. You're ending now? Yeah, I'm going to end now. secant and tangent lengths? Okay. Okay, for GED? Oh, okay. Whoa. All right. So I will see what I can do with the different lengths. Especially tangent with the point of tangency. The secant is not... That's with the chords and the philosophies. It's just really memorizing those formulas that are associated with it. And to know which one goes with which. That's the hard part, Ethan. Okay, that's the hardest part. Okay. All right. Take care now. Yes, not a problem. So that's trigonometry. Yeah, lots of formulas. Yes. So it's like more like geometry is what he's in need of. All right. Good night, Chocolate. You have a test on circles. Okay. All right. Good night, everyone. All right. I will see what I can do. I'll see what I can pull. If not, I'm going to see if I can get some more things that's going to be closely related to, especially the GED, because a lot of you guys are taking that exam in the next upcoming weeks. And some of those concepts are also being taught in classrooms today, nowadays. So I will try to blend the two as best as I can. Okay? I am only one woman. I am trying to do my best in this crazy ass world. Okay. All right. So thank you guys for coming out. I appreciate it. If you like, I'm going to do my shameless plug. If you liked how this notebook was kind of set up with the formula section, and then if there was any steps that you ever want to do, please, I designed this book. Yeah, I have a couple of them. All right, and they're all basically the same. 100 pages of the dot on one side and also the grids on the other, so you can actually do your own grids. You can do your own formulas and all these things. I'm thinking about selling my notes, so I think I should do that. In addition to the notes that's going to be in here, I also have a factor sheet. So when you need to do factoring, and I go from 1 to 200, so you can get all your factors in there, as well as, as well as like words to help with terminology, also the rules for integers, for adding, subtracting, and multiplying, order of operations. We did this one. We'll change Sally to Sabrina. And then we have the properties of exponents. So we worked on these tonight. Yes. Okay. Also the linear and quadratic equations, looking at the different equations that they have there, as well as a little bit of geometry. I'm working on the one for just geometry. I'm going to try to get that one out before next school year. For volume and surface area, I got the formulas for that. Going through the trig, we have, Pythagorean theorem, SOHCAHTOA, and all the identities, which goes into more advanced math, especially Algebra 2 and pre-calculus, and then the unit circle. So I have that, couple brain breaks just to help out, and this is what's called my Ultimate Math Notebook. So I am actually selling it right now through Amazon. So I have this as a cover, as well as the other cover that's also popular, little kind of same thing, same structure, same insides. It's just different covers. There's like 3 different types. Okay. So with all of that, if you have someone that's younger, that's 4th and 5th grade, theirs is a little bit different because I wanted to do with math tiles. So when they write their numbers, they can actually have numbers lined up and they can see it a lot easier. Okay, as well as everyone has mood trackers, so you can track your moods before the lesson, during the lesson, and after the lesson. And they also have the resource pages as well. They talk a little bit about fractions, give you some examples, place charts, decimals, how to do decimals. Okay, the same stuff that we have over here, but we add in the conversion charts as well as area and perimeter. And then also a writing example of solving the equation. So just to kind of give them an idea, things that we need to do, things that you just have to keep track of. So this is 4th through 6th. These guys are 7th through adults. So you'll have all your resources that you need. So the only things I need from you guys is, hey, if you can do a Google review for me, I will greatly appreciate it. I will actually see if I can copy and paste it and put it in the chat. I think I'm going to learn to do that in the beginning of our sessions because I know all of us are like ready to, pass out, go to sleep, I'm going to see if I can find my link, and a couple people already did, and I greatly appreciate you guys for doing that because the numbers are definitely going up tremendously. So if you want to copy and paste that, you can do that. If you can copy and paste, who knows if you can. But if you can't, just go to Google, look up ACG Math Tutoring, and if you could do a review for me, I'll greatly appreciate that. And another thing, if you could subscribe to my YouTube channel, Audrey Codner ACG Math Tutoring. And then, of course, I have to change this paper because my live's schedule has changed again. Every time I think I got it down, then might as well just scrap it and throw it away. All right, so, but definitely take a look. If you haven't, Professor TK, I'm not sure if she's still here. If she is, definitely follow her. If you know anyone that needs help with chemistry, she is amazing. If you want, I'm going to just throw some names in there for you guys to follow. So, Professor TK. Okay, she's awesome. Then we have Not remark. I always keep forgetting. Impact. Jeez. Impact math. 19 is another one. I always keep forgetting her name. But she does a lot of the stuff that I do that's very similar. And she goes on at 2 p.m. Eastern Standard Time, which is 1 p.m. Central Time. Okay, so she's always live and direct in there. If you have younger kids or maybe yourself that you actually want to learn how to learn how to do math with an abacus. And you're probably saying, well, what the heck's an abacus? An abacus, if you try to text the word math and you see like this little box with beads on there, that's an abacus. Okay, that's been around for centuries. Okay, it is a pure art form. And my friend Lynette, let's see if I can spell the word learning. Sheesh. And I think she only has one N in her name. Okay, so Learning with Lynette, she's awesome. You definitely want to do that. Do I do trig? I do trig. Oh yeah, Lynette's here. Hey. She's definitely the person to kind of go to. And another person, there's actually a couple more. A blessed RN. So if you are in a nursing program and you need assistance with doing dosage and don't want to have to memorize all these crazy formulas, she has like this awesome tactic that just makes it really simple. It's basically conversion, but the way she patterns it, you'll be able to catch on really quickly. So definitely latch onto her. And then I found this gentleman, I think it was yesterday morning, Mr. M, I think his name is. He's also a math teacher and a math tutor. And he was breaking down a lot of fractions. So if you are struggling with the basic arithmetic, like fractions and factoring, and you need to see someone before me or after me, go to him. He's awesome too. So this is my list. These are my peoples. So I just like to do all of this stuff. All right. Yeah, I'm telling you, go. Like Lynette, are you going to go live and do your midnight math or no? Because I will gladly send people over to you guys, to you. Oh my God. With the slide rule? Oh, why? That's like cringe for me. Cringe. I am that old because I just did not understand it. But you know what? I'm getting older, so I was like, about 30 minutes. Okay. So if you guys want to learn the basics of the abacus, definitely in the next 30 minutes, go see Lynette. She's always on. I thought I was bad. Nah, she's always online. Yeah, it's going strong. Yeah. It was there for a minute, but geez, that just really, yeah. No, it did not play well with me. But, Lynette is doing some awesome stuff with the abacus. Definitely with the abacus. So, if you do want to purchase a book, it is on Amazon. You can get it on my website as well. So, like, if you just click on my picture, go to my profile, go to my website. I have courses. I have one-to-one tutoring. I have my notebooks. And I think that's all I have for right now. I think for right now, that's all I have. Okay? All right. So I'm going to get off here. Lynette's going to jump on. And I'm probably going to jump on her live and a little bit later. I just want to kind of clean up a little bit before I pass out so I can get up bright and early and start my regiment all over again. All right. Thanks once again for coming in, guys. And I will see you tomorrow night at 9:30. All right, take care.